carbon cycle is a naturally occurring phenomenon involving exchanges of carbon between the atmosphere and the Earth. Carbon emissions are mainly from decaying plants and ocean evaporation, while precipitations and growing plants act as carbon sinks. But humans have disrupted that balance by increasing the rate of emissions of carbon dioxide through fossil fuel consumption, cement, and land use change. The excess carbon cannot be absorbed in its entirety by the ocean and land sinks, creating a surplus of carbon in the atmosphere. As a result, a greater portion of infrared emission from the Earth are absorbed by the atmosphere and re-emitted, creating a warming effect that we call climate change. In 2015, the country signed the Paris Agreement, therefore complying to an 80% reduction in greenhouse gas emission before 2050, with the objective of limiting the global effect of climate change. Since fossil fuel burning is the main source of emission, the success of this objective relies greatly on adapting our electricity system from the natural resource we use to the quantity we consume. While most provinces are working towards this objective, 221 out of 259 remote communities in Canada are still dependent on diesel as their main energy source for electricity and heating. 80 of those communities are situated in the territories, with 53 depending on diesel. The regions marked with a yellow dot on the map are powered by fossil fuel. Yukon's communities are partly serviced by a local hydro-powered microgrid. The Northwest Territories have a few villages powered by hydro, solar, or natural gas. In Nunavut, all communities use diesel. Because of this, the price of electricity in the territory is around 10 times the Canadian average. Most of it is subsidized. Renewable energy projects have a higher capital cost but are profitable on the long term. They also have the potential to reduce carbon dioxide emissions and avoid diesel spills and leaks. Some of the co-benefit of these projects include the creation of green jobs, clean air, and independence of communities. So how to solve the problem? Let's start by looking at what has been done successfully. Wind turbines have been tested in communities of Alaska and Yukon. They have also been tested in commercial mining setting in Quebec and in the Northwest Territories. The Canadian North has high wind potential. The cold air density also means that the extractable power is 10% greater than in the provinces. Kodiak Island, for example, with a population of 15,000 people, took a green turn when they decided to replace an annual 2.8 million liters of diesel, equivalent of $7 million, by wind turbines. The turbines now make up to 20% of the electricity, with the other 80% being provided by hydro. The highest wind turbines in the Canadian North stand on Heckle Hill in Whitehorse, Yukon, with a capacity of 800 kilowatts. They have been installed in the 1990s in a pioneering project. Because wind turbines have a high upfront cost and the logistics to install them in communities inaccessible by roads are complicated, solar panels are often a better choice for smaller and more remote communities. The case of Colville Lake is particularly interesting. The residents used to consume $140,000 of diesel brought in once a year on a risky winter road. With an aim to reduce diesel consumption by 40%, Colville's Dene First Nation, with their population of 160 people, installed 54 kilowatts of solar panel as well as a storage unit. Before the construction in 2014, the community was suffering from weekly power outages due to high demand. Except for larger cities like Whitehorse, hydroelectricity is not promising as water freezes over the winter when demand is at its peak. Because heating accounts for 74% of the diesel consumption in the north, both alternative heating solutions and demand-side options are also being considered. Natural gas heating systems, for example, can be easily introduced but with low impacts. Other solutions include biomass heating with wood pellets and geothermal energy. All in all, there is still only a small proportion of the communities that have switched to a hybrid energy system, and so much more progress can still be achieved. Learning from the past, only projects that were extremely well planned and were done in collaboration with local First Nations have been successful. When moving forward in integrating renewable energy in the Arctic, many challenges are yet to face, including the adaptation of technology to cold climate, transport to remote locations, policy, and availability of qualified workforce. In Nunavut, 15 out of the 25 communities operate on diesel facilities that are past their life expectancies. Actions need to be taken now. This will not only help Canada reduce its impact on the carbon cycle and reduce electricity costs for northern communities, but it will also empower First Nations by making them closer to their land and less dependent on diesel importation.